Alright, this is the last section of Chapter 16, Part 1, and so we're going to talk about isotopes. Alright, so isotopes. Isotopes are atoms of the exact same element but have different numbers of neutrons. So, for example, we have carbon. You have two carbons, but one is carbon 13 and one is carbon 12. And so you'll understand what this means just a little bit more here in a minute when we actually break down the two types of carbons. Okay, so, but understand that they both are carbons, and they'll both have the same number of protons, they'll both have the same number of electrons, but they have different numbers of, and I'm going to circle this, make this really well known. Let me get a different color because you're not going to be able to see the color I have. Just take just a second because it's being a little silly here. Here we'll get yellow. I think you can see yellow on here. Neutrons is the key word. Neutrons. Okay? Different numbers. Isotopes have different numbers of neutrons. Okay? Alright. So a couple things on the periodic table before we can go through isotopes. Okay? So everybody should have a periodic table at this point. Alright. So first of all, you have the atomic symbol. Oh. Gosh, I gotta hit that pin button. Makes all the difference in the world. Atomic symbol. Okay? The atomic symbol is the big letter in the box, okay? Then you have the atomic number, okay? That's the little number in the corner. The atomic number, like for example, a Be, which is beryllium, is 4. All right? Then, some other things that you might just need to know, and we'll talk about here in a minute. Average atomic mass is the big long number. It has a couple of decimal places. So like for copper, it's 63.546, okay? Then, of course, then you have the name of the element. So it's the big long name. So for the one that I have pointed there is boron. Okay, so that's kind of the breakdown of some things on the periodic table. There'll be other things that we'll be talking about later. If there's any other questions that you have, of course, come see me. But those are the big high points that we need to point out right now at this moment. Okay, so if you need to take out your periodic table, mark some things. Okay, hopefully that will help. Okay, so here's some helpful hints. Okay, so to find the number of protons, it's the exact same as your atomic number. Or if they give you the number of electrons, it's exactly the same. Okay, I'm going to skip down here for a second. Electrons, it's the same as your atomic number or the number of protons. Okay, so protons and electrons, these two, are the exact same. So these two numbers will be exactly the same. Okay, then go back up here. Neutrons. Neutrons, it rather has to be given to you, or you can subtract the atomic number from the mass number. And again, that might be a little confusing until we come down here to the mass number. And look, the mass number is the protons plus the neutrons. That's what we're saying. So, meaning that mass number is protons plus neutrons. And again, this will probably make a little bit more sense once we go through an actual example. This is your little cheat sheet. So if you forget, you can come back to this part in your notes and go, okay, how do I find this? Okay? So let's do an example. Okay, going back, carbon 14. Remember I said, okay, we have two carbons, carbon 13, carbon 14. Carbon 14 is an isotope of carbon. So carbon 14. Now, what does the 14 mean? This 14 at the end, oh, gosh, I gotta hit the pen button. Somebody's gonna have to put a post-it note on my forehead. Carbon 14, the 14 at the end tells you, this 14 at the end, if they ever give you that, that's your mass number. So that tells you your mass number. So that's this right here. So they gave you some good information. Okay, so you have that. Now, that's all you have so far, except for you have the name of the element, which means you can go to that periodic table and you can look up carbon, meaning I can go back up here a slide or two. I'm going to go back up. Look, okay, go back up. Look, I can look up carbon right here. Carbon, and look at this number right there, 6. 6 is my number of protons because it's my atomic number. Remember that number in the corner is my atomic number. So 6 is my number of protons. And remember, if we get back, I think one more slide here, remember, protons is my atomic number, but remember, electrons is also the atomic number. So I said this was my mass number, right? So that's 14. I went and looked at my periodic table and I said the protons was that 6. And I said the electrons was the same as the protons, 6. So now all I need is my neutrons. But if I go back and I look at a slide above, and remember I'm not going to go back, it's in your notes, you can look. The mass number, this here, is protons plus neutrons. And just FYI, protons is abbreviated P+, neutrons, and with a little 0, electrons, like that. Those are the appropriate abbreviations. So, mass number is protons plus neutrons. So, mass number, so if I take my mass number, which is 14, and I subtract off the protons, which is 6, that will give me my neutrons. So, in this case, 8. Okay. All right, let's try another one. Magnesium. Alright, so magnesium, which we should be starting to learn these elements a little bit. Magnesium is Mg on the periodic table, just to help you out to look. So if I go and I look up Mg on the periodic table, it's number 12 on the periodic table, by the way. So that helps me. So number 12, so if I go and I look, number 12 is the protons. And then so that means the electrons are 12. And then, so if those are 12, then all I have to do then for the mass number, remember, is take protons plus neutrons. So in this case, they gave me the neutrons. So 12 plus 14, which is 26, right? That's it. Not too bad. Okay. All right. Alright, now, another way that we write the symbols of things, specifically in nuclear form. So if we're going to do nuclear reactions, we write what's called a nuclear symbol. And this is the nuclear symbol for elements. So you'll notice that we put the symbol in the middle. So we call that X. And again, I don't know who came up with this. This is just the generic, like, what do you call that? Like a key. Like, this is how you would do it. This is just to show you how to do it. This is not a particular element or anything. There is no element X. This is just a plug and chug type of thing. So X would be your element or symbol. So, you know, carbon, the C would go right where X is. A is your mass number. And again, I don't know who came up with this. I would use letter M for mass number, but it's A, okay? So your A is your mass number, and your Z is your atomic number. And again, I know that's a little confusing, but this is the way that Mr. Chemistry some time ago put this together. So just go with it. So A is mass number, Z is atomic number. And here's your, here's how to do it. All right? So let's go through an example of how to do a nuclear symbol. All right. So write the atomic symbol for the isotope with the number of protons 27 and the number of neutrons 31. Okay, so here you go. So they're saying you have protons equals 27 and neutrons equals 31, and they want you to write a nuclear symbol. Okay, so already they're telling us protons are 27. So you can go and look up number 27 on the periodic table, right? 27 is cobalt. So cobalt, I'm going to write CO. That's my symbol. And remember that you have, X, and then you have AZ. Remember, that's what your final product should look like. And I know it's hard to see because I'm using yellow down there, but that's what it should look like. So I have already my symbol here. The A is your mass number. So we need mass number. Remember, you find mass number by taking your protons and adding your neutrons. So I'm going to add those for 58. So that goes up here. And then your bottom one is your Z, which is your atomic number, which is your same number as your protons, which is 27. So look at that. 58, 27 cobalt. That's what you write. Okay. Let's try another one. Write the atomic symbol for the isotope Z equals 12 and A is 23. Wow, this one they're even trying to take it easy on you. They gave you the A, which remember goes in the top corner, so 23. They gave you the Z, which goes in the bottom corner, 12. So all we have to do is look up the atomic symbol, which is based off of Z, your number of protons, which is 12, which is Mg. So there you go. Looks like that. Okay. And I think that's it. Yep. Oh, nope. Atomic mass. One more thing. So, now we have the mass number, which is the mass of each individual isotope. But when we talk about atomic mass, we have, first of all, that we have the mass, of course, most of the mass is found within the nucleus itself. The mass is the protons plus the neutrons, and the mass of a proton is about equal to the mass of a neutron itself. The mass of an atom is actually so small that we actually give it its own individual unit called an AMU, and the mass of a proton and a neutron is almost 1 AMU. Electrons are usually not considered within the mass themselves because they are usually so small that we just don't even count them. Now, most elements have more than one mass, like we talked about at the very beginning of these set of notes. Carbon has actually 3 different isotopes, carbon-12, carbon-13, and carbon-14. So what they do is that they take the average of all, what's called a weighted average, kind of like your grades, you know, in here. We have 30% tests, or 50% tests, 30% homework, and then, labs and all that stuff. And they put it all together, and then that's how they get the actual mass that goes on the periodic table. And so they take the average atomic mass of all of those different isotopes, and that's where they get the numbers on the periodic table. So that's why if you look up carbon, for example, on your periodic table, the mass is 12.011 because most of the carbon that exists on this planet is carbon-12, but there is a percentage of carbon-13 and carbon-14. So that's where they get those masses on the periodic table. It's based off of the different isotopes of carbon. And I do believe that is now the end.